Hello, 8th graders, and welcome back. Here is the next lesson of this unit. So within our final unit, we are doing 10.2, which is about the product of power property. Okay, so here is your different I can. So I can multiply powers with the same base. I can find a power of a power, and I can find a power of a product. So we're going to talk about what each one of those mean based on using your exponent powers. Skipping our warm-up. All right, essential question. How can you use inductive reasoning to observe patterns and write general rules involving properties of exponents? So if you've already kind of taken a look at your notes here and trying to figure out kind of what might be your answer here, maybe you're given the problem and you're given the answer, but you're not given the directions on how to solve it, okay? So how can you use that inductive reasoning to observe the patterns and come up with a general rule? Now, that's something that you're kind of realizing right now, given our current situation. Now, I'm going to try my best to go through and explain all of this, but sometimes you might have a question and I'm not there to help you right away, okay? So this is a really good skill to have to kind of look at the patterns of what are the things you're noticing, what kind of answers are they given, and how are you going to use that to actually figure out the problem for yourself if you were given the problem. All right? So we've got a lot of notes on this one. Again, I'm going to kind of move myself around as best as I can here. Maybe move myself a little bit. All right, so first one was talking about the product of powers property. What this means is to multiply powers with the same base, add your exponents. So you might see something like this, where it is 4 squared plus 4 to the third, okay? What this means is then instead of figuring out what is 4 squared, okay, 4 squared is 16, and multiplying those all together, I'm just going to combine those exponents. And so what I do instead is I add my exponents. So the base stays the same as 4, and then I'm just adding that 2 and that 3 together. So then my answer is 4/5. Okay, simple enough. This is what happens when I multiply it, though. Make sure you're understanding this is being multiplied, but I don't multiply my exponents. I add the exponents. Okay. The other one is then the power of power property. To find a power of a power, multiply the exponent. So it means you're taking a power and you're raising it to another power. So it's almost kind of like saying that this is 4, 6, and then you've got even to a third, okay? What this is that you're usually going to see it within these parentheses. So you're going to have the base is 4, you've got a power of 6, and then you're also taking this to a power of 3. This is the case where you're going to multiply the exponents. So you're going to take 6 times 3. This gives me 18. So now I have an answer of 4/18. I don't actually want to know what 4/18 is yet. I just want to simplify this. Okay, so we're not actually evaluating the expression in a sense. Okay, we're kind of simplifying it, making it a little easier to read. And then the last one we're also going to talk about is the power of a product's property. Okay, so this one is kind of like your distributing property in a sense, where if you have 2 different bases on the inside being multiplied by each other, I could, multiply these together and do this, but this is what it really means, is that this 5 is being distributed to each part. So it's going to mean that I have 3 to the 5th times 2 to the 5th. Okay, that's what this means within here. So you're distributing that exponent of the 5th to each base on the inside. All right, feel free to come back to this at any point that you need to in the lesson if you're not sure on the rules as we're going through. Now, it is kind of hard to remember each set of rules when they're always like product of powers property, product of power property, product of property. There's a lot of different ways to rephrase the same kind of thing or different ways. There's lots of P's in these expressions. So it's easier to kind of come back and look at this diagram to realize, okay, am I multiplying them? Am I taking the power of a power? Am I using distribution basically to distribute this exponent? All right, so let's go to the first example. This first example is a lot like the one we were just talking about. So this is my product of powers property. I've got the same base, which is 2. My 2 to the 4th is being multiplied by 2 to the 5th. So ultimately what ends up happening, if I go back and look at these notes, is the base stays and I'm just going to add my exponents. So my base is still 2, and then I just add the 4 plus the 5. 4 plus 5 gives me 9, and my answer now is 2 to the 9th. Right? Same thing happens in this one. Now, I do have the same base. I've got -5 and -5. This one, though, if you notice, doesn't have a power next to it. If it never has a power next to it, assume that the power is 1. Okay? So in this case, again, my base is going to be the same. I've got -5. I add my two exponents together, 1 plus 6, that gives me an exponent of 7. So I've got -7 or -5 to the 7th. And the last one here, again, my base looks to be x for each one, so I'm going to have it x. And then I just add my exponents. 3 plus 7 gives me 10. So I have x to the 10th. Okay. Feel free to pause this video, go back at those notes if you need to double check your work. Feel free to let me know if you've got questions, but for right now, we're just looking at that product of powers property. Okay, so adding in your exponents and keeping the base the same. All right, example 2 then is that next property. So if I go back and look, that is the power of a power property. So in this case, you're going to have one base. It's going to be raised to an exponent, and then on the outside of this parentheses, it's also going to be raised to an exponent. What I need to do in this case is I multiply these exponents. So I keep the base the same as 3, and I just take 4 times 3. 4 times 3 gives me 12, so now I have 3 to the 12th. I don't actually want to know what 3 to the 12th is. All you're doing is just simplifying it right now. Okay. Same with this one. It looks to be that I have a base of W. I take the 5 times the 4, and I do 20. Again, these ones are you're multiplying your exponents. That's all I'm doing. Okay. And my last one, I would assume we're looking at that last property. Okay, so let me go back and look. This one's your power of a product's property. So that's where you're going to distribute that exponent to each part that is in the parentheses. All right, so you have two different bases in here. Basically, what this problem is saying is that you have 2 times x. So when I do this, I need to distribute this 2 or this 3 exponent to both the 2 as well as the x. Okay, so I'd have 2 to the 3rd and x to the 3rd. Now, sometimes when you're given variables like this, you will see then that if it has a base of a whole number, that it will be evaluated, meaning you're going to actually have the answer. So 2 times 2 is 4, times another 2 is 8. So sometimes you'll also see this as 8 and x to the 3rd. Okay. Same with this one then. It means we've got 3 things on the inside. I've got 3 times x times y. Again, I need to distribute that exponent to each part. So it's going to the 3 as well as to the x and as well as to the y. So in this case, I'd have 3 squared and x squared as well as y squared. Again, you'll usually see that that constant evaluated. So that 3 squared, which is going to be 9. So in this case, you may see it, ooh, that 9 is not good. Sorry guys, I'm trying my best to write a 9 here. So 9x squared, y squared. Okay. Again, pause the video if you need to. I know I'm going through these a little bit fast, but let's keep going. All right. As best as you can, I'm going to try and kind of, let me get rid of myself here for maybe just a sec here. Go ahead and try these ones on your own. Okay, follow those rules. If you need to go back to that other slide to see those rules, you may. Okay, whenever you are ready, come on back and I will show you the answers and go through the problems. All right, hello, welcome back. Here's my answers to these on your own. So your first row was where you have the same base. You're multiplying those bases And all you're doing is you're taking that same base and you're adding your exponents. So adding the 2 and the 4, you get 6. In this case, the 3 and the 6 is 9. And this one, remember, this is going to be an exponent of 1, so 1 plus 12 is 13. Okay. These ones, you multiply those exponents, so I'd have 4 to the 12th, y to the 8th, and then negative 4 to the 6th. On 7, 8, and 9, I had already taken that that constant and multiplied it by 4, 5 to the 4th, multiplied it to the exponent of 4. Is 625 y to the 4th. Then you get a, this one you need to make sure you read it to both parts, okay? A to the 5th, b to the 5th. And this one, when you make 0.5 squared, you get 0.25, and you have m squared and n squared. I should not see mn squared, okay? This is not Minnesota squared. You need to take each letter within here and square it. This does not count, okay? So make sure you break it apart on each part. All right, let's keep it going. I'm just trying to see how much examples we have. I think we can make it through this in just one example. All right, so, or one video. This one's example 4. It says the gigabytes of a computer storage space is 230 bytes. The details of a computer are shown. How many bytes of total storage space does the computer have? So how many bytes does this computer have? Okay. So computer storage, it looks to be that it has a total of 230 bytes. Here are your free space. Here is your total space. Okay. Hey guys, somehow this didn't transfer right, and this is where I was getting a little stumped. So this is actually supposed to be 2 to the 30th. Not sure why that's coming in as 230, okay? So the 2 to the 30th bytes, and so that's why I am seeing that, okay? So the gigabytes of a computer storage is 230 bytes. The details of the computer are shown below. How many bytes of total storage space does the computer have? So this is like an extra amount of storage that you can add to your computer, okay? So back when computers used to not hold as much storage, people would have these local disks, or they'd have floppy disks, or they would use disk drives. People called them, I call them junk drives, okay? So what it's showing is that you've got some extra amount of space here as well, okay? So to figure out how much total space is, I'm going to take this value, so this 230, and I'm going to multiply it by the additional space that I have here as well, okay? All right, so I'm going to use the total space that is available in this extra part, okay, which is 64. But if I want to multiply these, I want to keep this at the same base. So I want to think 2 to what power is going to give me 64? So plug in your calculator. Okay, 2 times 2 is 4, times 2 is 8, times 2 is 16. What are you going to get? 2 to the what? If I do that, I end up getting 2 to the 6, gives me 64. Okay. So I'm multiplying them together. When I do this, remember your base stays the same, and you just add your exponents. So 30 plus 6 gives me 36. So based on this, I would pick your answer as B. Okay. That's how much total storage, if I'm going to keep it in exponent form, that my computer would have. If I wanted to convert this, though, let's see what this would be. This has got to be crazy. Oh, will it let me? 2 to the 36? I bet it'll. It's going to give me scientific notation. So that's something that we're also going to learn later on in this unit. All right. We're not going to worry about this part. Don't worry about it. Okay. Let's keep going. I'm not going to do closure either. Again, if you don't want to, you don't need to do these workbook pages, but it would be good extra practice if you would like to. Your assignment that you need to get done this week then to go along with this lesson is that 10.2. Okay. So I will be looking for that, and it'll be due that Sunday. Let me double check what day is that. That's going to be the 19th. So again, make sure to get that done by the 19th. Okay. So 10.2 on Big Ideas Math. If you're ahead of the game, Remember, I'm not going to have these uploaded until the week of. So big ideas will not be put on to